Hello everybody, my name is Hello. Welcome to this video series where we're solving Codeforces problems in Python. We are doing the A to OJ ladder, and in this video we're going to be doing problem 165A, which is called Supercentral Point. Let's just go ahead and see how to solve this problem. Okay, so let's go ahead and read this problem. One day Vasya painted a Cartesian coordinate system on a piece of paper and mark a set of points x1, y1, x2, y2 up to x and yn. And a Cartesian coordinate system is something like this. And there will be points denoting by x comma y. For example, this will be, let's say this is 2 here and say 3 here. This will be 2 comma 3. Okay, so let's define neighbors for some fixed point for the given set x comma y. Point x bar y bar is x y's right neighbor if x bar is greater than x and y bar equal to y. That means, let's say we have some point here. This point will be for y is equal to 0 because the y is same, x value is differing. This will be its right neighbor. Similarly, x bar y bar is x y's left neighbor if x is less than x but y is equal to y. So this will be the left neighbor. And similarly, there's one more thing you need to keep in mind. What about up and down neighbors? Up and down neighbors for this particular point right here will be x value will be same but y value will keep differing. So some things like this. This will be the up neighbor and this will be the down neighbor. Okay. We consider the point xy from the given set supercentral if it has at least one upper, one lower, one left and at least one right neighbor among these sets of points. They're saying this particular box that we have put here, this point is a supercentral point because it has one left neighbor, one right neighbor, one up and one down. So at least if you have one of those, this point is called a supercentral point. Okay, so we are given a set of points and the number of points. We need to find out how many supercentral points exist in that particular set of points. So this is what the input looks like. How are you going to find that out? Okay, so given a set of points, see, one way to approach this problem would be to just take all of these points, right, and then maintain a list of neighbors for all of them. Then you go ahead and find out whether something supercentral point exists or not. To approach this problem, there's two things we need to keep in mind. First, we need to keep track of neighbors, okay, in the points. So we need to keep track of all the points, obviously, along with the neighbors of each of these points, because only if we are able to get the neighbors, we can check for supercentral, correct? Supercentral, I see supercentral. Okay, so how are we going to keep track of the neighbors first? Because then only we can go ahead with the rest. My idea here would be to keep a dictionary for all the x values and all the y values. Here we will say for some particular value x, what are its up and down neighbors? Okay, that is what we're going to be saying here. So for example, in this case, x is equal to 1. So we'll put 1 and this will have a value of, see, is 1 being repeated somewhere? Yes, first 1 is also there, yeah, and then we have 2 and then again 1 is here, 0 and 3. So what this is like, we are just saying the points 1 comma 1, 1 comma 2, 1 comma 0 and 1 comma 3. In this particular case, we are only taking all the points that is required for it. And that will look something like this, right? So for x is equal to 1, this will be x is equal to 1. We're keeping track of these points. So this 0, 1, 2 and 3. So in the future, if we take some point like this, we can check if some point is below it, some point is after it. We can say it has up and down neighbors, because for supercentral we need to find, because for supercentral we need to find out whether it has up neighbors and down neighbors, right? As well as left and right. In this particular case, we're dealing with up and down neighbors. So but see, keeping track of all of these neighbors is also a hassle, because you have to look at what is the minimum element every time, what is the maximum element every time. You need to check for any value here. If there is something greater than it, something less than it, that is something that is a bit time consuming. So instead of that, let's take a different approach. See, for these sets of points right here, right, let's say we have, okay, so let me just draw one line here so it's more easier to understand. Let me take a particular set, like, so there are 4 points over here, or let's say there are 1 2 3 4 5 6 points over here. Now tell me, for which set of these points are there up and down neighbors? This point, it has one up neighbor at least, one down neighbor at least, yes. This point also, yes. This point, yes, at least one, at least down. This point also, yes. But these 2 points right here are the only points which do not have up neighbor or down neighbor both. In this particular case, there is no up neighbor. In this particular case, there is no down neighbor. So if I'm able to keep track of this point and this point, then I can say if any point that lies in between these two ranges, it is guaranteed that it will have an up and down neighbor, because this is the down neighbor, this will be the up neighbor for those points. So what I'm saying is, instead of keeping all of these points here, I will keep track of 2 points alone. I'll keep track of the minimum point and I'll keep track of the maximum point, and I'll keep updating this value. So what that look like, initially I'll set the minimum and maximum to be 1 in this particular case here. Then the next time this comes here, it will be 2. So 2 will not be the minimum, but I'll go ahead and update the maximum value here. Then it will be 0. 0 will be the new minimum. Then 3 will be the new maximum. So I'll represent this by 1, 3 or 0, 3. I'm sorry. For the x value 1, the minimum y coordinate is 0 and the maximum y coordinate is 3. In case in the future, if I have some point like this 1, 2, I will say if this 2 is greater than this value and lesser than this value, then it is guaranteed that that point has an up and down neighbor. So that particular check is done. Next, I need to do the same thing for left and right neighbor. This exact process I can repeat for these y values. Let's take some y value, say y is equal to 2. Okay, so let's see, this is one value, this is one value, this is one value, right? So this will be what? 4, x value will be 4, x value will be 1, and x value will be 0. These are the 3 points that is given to us. Instead of doing this, we can again keep track of the maximum and minimum value. In this particular case, the minimum value is 0, the maximum value is 4. So in case of 2, y is equal to 2, this will be right here. The minimum value will be this, the maximum value will be x is equal to 4, right? So any value in between this will have both left and right neighbors. So that is what I'm going to check. In case we are having a point, say something like 1, 2, or yeah. So in this particular case, this value will come somewhere here. Yes, this will have both a left and right neighbor. So if this is greater than this and less than this, it is guaranteed to have. What if you get the edge case? What if you get something like 4, 2 again? In this particular case, you know that this is the maximum value, therefore it does not have a left and right neighbor. It may have a right neighbor, it may have a left neighbor, but both of them aren't guaranteed. So those cases will be something that is failed. Once we know this information, we can simply say, once we are able to construct this dictionary for all the points that we have, we can again iterate through all of these points right here and then check if for that particular x value, that condition is satisfied, where it is greater than the minimum, less than the maximum. And for that particular y value, if it is greater than the minimum and less than the maximum. Once both of these conditions are satisfied, we can say that it is a supercentral point. And I hope you're able to understand, because this condition right here will tell us whether it has upper and lower neighbors. This particular condition will tell us whether it has left and right neighbors. If both conditions are satisfied, it is a supercentral point. If you're able to understand how we are approaching this problem, I highly recommend you to code this for yourself. If not, stick around for the code. Let's see how that looks like in Python. Okay, so let's go ahead with the code. Firstly, we need to input this n value. Then we need to keep track of, see, as we discussed, we need 2 dictionaries, right, to keep all of the x points and all of the y points. So we can define that as dx and dy. Then we need to take input of all of these lines right here, and that will be for underscore in range of n, right? Because we're repeating that input for n times, what we'll do is we'll go ahead and take these values as input. So that looks something like x, y will be equal to list of map of int, input dot r strip dot split. We're saying for every single case, we're going to be looking at the x and y value. We're taking that as input. Okay, so first let us check if this x is not in this dx. Okay, or y is not in dy. So if x not in dx, okay, in that case we can go ahead and start this particular x value, right? We can initialize this. So dx of x will be given by a list, and this list will be, structure of that list will be minimum element comma maximum element. Okay, and 0th element will be the minimum element for that particular x, the y value is the minimum value, and max will be the maximum y value. Initially, let's just initialize both of that to be y. Okay, and now we're going to say, what if x is not in dx? What if x is not in, and then we're going to say, what if x is in dx? Okay, if x is in dx, if x is in dx, check if x is the minimum or max. In that particular case, we'll say, if y is less than dx of x of 0, in that particular case, set this value to y. sorry, this value to y. If y is greater than dx of x of 1, set that particular value to y. Dx of x of 1, set that to y. Okay. Similarly, we have to do all of this for y as well. Okay. So we'll check if y not in d of y, in that particular case, d of y of that particular x value will be x comma x. Else, if y is there in the dictionary of y, we will say if that particular x is lesser than dy of y of 0, in that particular case, we'll set this value right here to be x, and we'll also check if x is greater than dy of y of 1, in that particular case, set dy of y of 1 to be x. Okay, once this is done, let me just go ahead and print this and show you how this looks like, dx, and then we can just go ahead and print dy as well. Okay, so look, for all of these values, it looks something like this. So these are the different x values. We have x is equal to 1, x is equal to 0, x is equal to 3, and x is equal to 4. So 1, 4, 3, and 0. For each, it will keep track of the maximum and the minimum value in those particular places. Okay, those particular x values. Okay, now we are going to go ahead and iterate through all of these points again. We're going to check if this point is between something or not. So for that, we need to keep a copy of all of these points so that we can iterate through those points, correct? Right now, we are not able to keep a copy of this. We are just initializing and keeping track of all the neighboring points. We need to keep track of all the points also. So for that, what we'll do, we'll just create a list called points, and for every x and y, we'll just go ahead and append this points dot append. Let's just append a tuple like x comma y. Okay, so once we are able to do this, what we'll do is we'll iterate for x comma y in this particular points. This will actually parse this particular tuple and it'll give both of these points for us, all these set of points. So if we're able to find, I can actually print out points as well for you guys, and see, this is what points will look like. We're going to iterate through every element there. So yeah, then what I'm going to do is I'm going to see, I know this x and y value. I need to check if x value is the max or the minimum. In that particular case, the supercentral point won't be there, else there will be supercentral point. So I'll just super points. So this will be the number of supercentral points. Now we have to say, how do you check that particular value? See, let's check for the x point. Minimum is 0th index and max is first index. Keep that in mind. Okay, so what we'll do is if d of, okay, so if y, since we are checking for the dx of x point, we'll say if y is greater than dx of x of 0 and y is less than dx of x of 1. In that particular case, now check for the y point, and that we'll check by saying if x is greater than dy of y of 0, same thing only, and x is lesser than dy of y of 1. See, both of these are the same only. You can check both in any order you want, but at the end of the day, both these conditions should be satisfied. In that particular case, it will be a super point. We can go ahead and include it by 1, because as we discussed here, if both of these conditions are active, at least they have one upper and one lower neighbor, at the same time one left and right neighbor, so they are a super point. We can just go ahead and print all of these super points now. Okay guys, sorry, I made a very small mistake here. This should be d of y. Okay, this should not be x. I just copied all of this and I forgot to change that, because we are keeping track of all the x values and all the y values. So I put that x by mistake. It should be y. Okay, and let's just go ahead and run this code now. You can see both these test cases passed. I'm going to go ahead and submit this code as well, because you guys should know whether this code works or not for other test cases as well. That's it guys. I hope you're able to understand, except that particular case where we made that silly mistake. That's it, this code. I hope this helped you. If you guys have any alternative approaches, let me know down in the comments. Right, as you can see, this code got accepted. I hope you're able to get something out of this. If you guys have any questions, obviously let them know down in the comments. I'll try to answer it to the best of my abilities. Thank you so much for watching. Bye.